Guys, welcome back to Spanker Ranch Garage. Tonight we are working on the angle bracket on my John Deere 450B bulldozer. This is the 6405 6-way hydraulic blade. You'll see this same exact blade all the way from the original 450 all the way up to like the 450E probably, before John Deere went with a little different blade that's got like a ball joint knuckle for the pivot and tilt. This is a very, very common blade. It's a very good blade, but mine is worn the hell out. So if you haven't checked out part 1 to see how bad this was, I'll post a link right up here to that. Give that a look first. We are midway through welding and machining right now, so let's get started. So these angle cylinder bushings have seen better days. Looking down here, you can see that this is more of an oval than anything. And this top part here is pretty egged out as well. Here's a look at how that factory 1.5-inch pin fits in here. And then you can see down the bottom here, we've got quite a bit of slop as well. This is just, I don't know, maybe just worn out or someone's manipulated it over time. I'm not exactly sure, but I can tell you that this is no good. So on the other side here, similar issues on the top bushing, absolute trash. But on the bottom, somebody already welded in a new bushing, or attempted to weld in a new bushing here to offer a lot more support on the bottom of that pin. And that bushing actually fits decent. But we're gonna go ahead and replace all of this. I decided that I think my best course of action is going to be cut all of the welds off of these factory bushings, manufacture new bushings, and then weld it all back together. And on the plus side of that, I think I'm actually going to build up this bottom bushing to be taller, to offer more support on the bottom side of this pin. This side, I don't know if it's worn or what, but I picked all the dirt out of here. This bushing's almost flush. You're not getting a lot of pin engagement in here. That's all you're getting, that little bit. And you know, by the time that wiggles around, there's just not a lot of engagement on the pin there. So I'd like to see at least a 1/2-inch bushing here. We have all kinds of space in here for the rod eye. The cylinder only takes up about 1.5 inches of this. We got all this extra room, so let's use it. Not my prettiest work. Got into the base metal there a little bit, but nothing we can't clean up. So essentially now we've knocked that bushing off the top of this C. That's what it used to be. Now we'll knock the bottom one out, make bushings, make a pin, drop the pin in, burn it all back together. Good as new. Well, it's got to look worse before it can look better. So you can see here I gouged out the welds, pulled that top bushing off. Same thing down here with that bird crap one. I have a lot of cleanup left to do here. I'll probably come in with the torch and just start grazing this weld off and then hit what I can with the grinder. Same thing over here, same thing over here. Right, it doesn't matter how much you gouge into this because we're going to put a bushing over this and burn it all back in anyway. So I just want the bushing to have a decent place to sit here, so I got to knock these high spots off. Yeah, knock the high spot off of that kind of thing. Now the rod, the eye on the rod is 1.75 inches high. John Deere gave us 3 inches within here. So I'll allow a 1/4 inch of play. We'll make a 1-inch tall bushing for the bottom side. Just to keep it simple, we'll make a 1-inch tall bushing for the top. The factory stuff was only about 3/4. And then also the pin does set down into the factory retaining hole here as well. And I just chiseled all the crap out of those. Actually got it back to a point where a pin will go into them. So the factory pins, man, they're just really minimal in engagement depth. That needs a little clean out still. But anyway, once we get the bushing stack together, we'll measure our full depth and we'll make a pin that is plenty long to replace these old ones. Got my money's worth out of this blade, but I haven't gotten myself one of the cold cut saws yet. So these things have treated me well. They just make such a mess. It's insane. Wait until you see the poop stain in the snow when I'm done cutting these 6 pieces out. And no, I can't just part this on my lathe. My lathe is really small, really floppy. Parting anything this kind of thick, no way. Not a chance. We got a brown skid mark coming out of the shop. All right, first bushing, fresh off the lathe. Fits over that 1.5-inch pin nicely. So we need to make 4 more of these. Because I only have a 4-jaw for this lathe, I have to dial every one in individually, only for the front face and for the boring operation. The back side is more cosmetic, so I'll just wing that. It takes time. That's what I want. It's not a hot dog down a hallway. It's a good gliding fit, but no excess play. So the other thing to consider is when I'm welding all this together, stuff's gonna warp a little bit and nothing's gonna be perfect. So even with a slip fit like this, I'm probably still gonna have to hammer these pins in for the first time. Now once you smash a few boulders, crack a couple beers, slap the blade around a little bit, I'm sure everything moves like it should. So anyway, we face this off, put a chamfer on the inside, then I put a fat chamfer on the outside. That's going to be my weld fillet. That way I can come in there and burn this down into that angle frame. All right, got all the bushings machined. Nice and happy. So really the vision here is now you've got 2 fresh bushings and a fresh pin. It's pretty much with the pin in here. I'm going to burn around here. Lock these pins in. Before I do that though, it's important that I drill across a through hole through this one and the pin at the right height, and then I'll either reinstall the factory John Deere roll pins or I'll use just bolts. I kind of feel like just using a bolt is a better for me option. All right, so I got my first pin and bushing set here. Not pretty with the welds, but I'm always trying new things with stick welding and I'm learning as I go. Anyway, I'll probably use bolts instead of the John Deere pins. This is just 1/4-20 that fits through here. Pull that out, and then the top of the pin I threaded to 1/2-13. So you can put this puller bolt in, and then with a little slide hammer action, the pin will come right out. So it fits really good, everything's lined up nice. I think this will be nice for long-term durability as well as service. Cannot forget about the serviceability side of it, because likely I'm going to be rebuilding these cylinders before you know it, and I'll probably be doing it in the woods. So I want to be able to get this thing out pretty easily. A little bit of welding distortion on the bushings, so that's something I didn't consider. The pin takes a gentle tap to fit it in, but nothing crazy. I did probably make them a little too tight to where you have to pull it out, but either way, it's going to work just fine. There's absolutely no play in the bushing at this point, and that's probably the way it should be, because the actual rotating portion and the greasable portion is the rod eye of the cylinder. So I think having a nice snug fit on the angle frame is where I want to be. Now when you're hammering things into a blind hole, don't do that. That's stupid. What happened was the bushings were super hot from welding, and I went to test fit the pin to fit okay, and then everything shrunk up to the same temperature, and this thing was seized in there. And I don't have the top machined yet with the 1/2-inch thread to pull it out. So I had to build this little puller. Just welded a piece of all thread to it. It worked out good. But just another little delay and another lesson learned on my end. So all right, we are done with rebuilding our steer cylinder pins and bushings. Man, the weld looks really bad on camera. It doesn't look that bad in person, I'll tell you. But some paint will cover that right up nicely. So far we fixed 3 of the 4 elements of slop found in this angle bracket. First being us building up these surfaces here, making this big repair on the center pin, fixing the angle cylinder bushings, and now we need to make bushings for the main angle pin. So I bought these bushings from John Deere. I think they were like $50 each, which kind of hurts to swallow, but there's actually 4 of these on this unit. 2 of them are on the C-frame on the actual Dozer, and 2 of them get pressed into here, and then there's a sleeve that's supposed to go between them to stop everything from moving. Unfortunately, this bracket is just too hammered to use a factory bushing. It's just flopping around in here. So we're gonna make our own. That's why I only bought 2 of these. These are for the actual Dozer outside. I didn't want to be dicking around with this for hours and hours in the snow. So I'm hoping that the C-frame on the Dozer isn't too egged out to use these, or if it is slightly egged out, I can weld these in. But for the purpose of this angle bracket, since we are in the shop and it's a little easier to work on, I'm gonna make bushings from scratch for this that fit really nice in here, and then we'll weld them in from the bottom. So we know this is for a 2-inch pin. Looks like John Deere has added a 3/1000 clearance fit to that pin. So we're gonna shoot for this same inside diameter that John Deere did, just with an OD and a shoulder that fits our wallered out frame here. All right, guys, I'm pretty proud of this bushing. It really didn't take too long. Banged this out. It's probably the biggest bushing I've ever made. I got a really little lathe over there. It's really pushing it with this, but you take your time, know your machine. This turned out awesome. We hit every dimension I was looking to hit. Nice fit over the pin here, no play, but moves nice and freely. And then we made this 2753 on the OD. Now you'll notice that I have made this substantially taller than the John Deere bushing. The reason for that is the way John Deere did this is they put a bushing in the top and bottom of this with then a spacer in the middle, which I'm not really sure what this spacer does other than just keep some junk out of the, keep junk off the pin maybe or whatever. But as my bushings got blown out and actually moved in the bracket here, this thing got all flared and destroyed. So basically the new intention is to just eliminate this. I'm gonna build really tall bushings and press them in, weld them in, and then we won't need this spacer anymore. Second biggest thing about this is, with the John Deere design, I'm not harping on their design at all, they knew what they're doing, but they only have an 1.5 inch of pin to bushing contact on the top and the bottom. Now we'll have 3 3/4 inches of pin to bushing contact. So while the pin that I'm manufacturing from and this bushing is probably softer than the OEM stuff that John Deere would give you, I have so much more contact area, I think it'll really slow the wear down, and this will probably last the life of the machine. I'll give it a push and see how it looks. Oh, baby. Oh, way easier than I thought. No problem. Almost there. A little percussion maybe. really turned out nice. Fits good down here. I could put a little weld on this and build this up as this surface has had a rough time, and maybe I will burn this in with a welder and then grind it smooth again. But up here, I can lay a nice fat bead on top of this plate. Should be no problem there. Plenty of meat to get into. Cool. So let's release the jaws. All right, and that bushing's in there. Now we're not gonna weld anything until the top bushing's made, pushed in, and put the pin through. All right, so I got the final bushing wrapped up here. Specifically made this the exact dimension to slip in here. There's hardly any room to spare. Now this one doesn't have as nice of a press fit as the one in the back does, or the bottom one does, but that's okay. So before any welding takes place on this, I'll be putting this pin through to keep us all in line here. I'll get started on welding these in, and then what I'm also gonna do is make a spacer for this right here to take up this slack. My thoughts with that are, you know, after years of beating this thing around, if these holes start to open up at all, because it's not really a great press fit, and the welds crack, they can't go anywhere as long as they're retained in the center here. And now that I think of it, that's probably the intent of this sleeve that John Deere put in there, is to prevent that. So you've got a C-frame on top of this and on the bottom of this, and then those bushings are retained by this pin that actually had a nut and a washer on it to kind of squeeze everything together. So once this is all assembled, there's really nothing that can come apart, or it's all kind of just fit in there. So it moves, but it got tight. This is why real line boring is important, and something maybe I'll look into in the future. I've always had like a little thought of using a mag drill to drive it, and setting up some bearings, and actually being able to do this kind of stuff. It wouldn't have fixed my old situation, but in this situation, if I made these bushings small, weld them in, and then line bore them to size, that'd be the ideal way to do it. But this does go through for now. We'll see after I flip it and weld this one how screwed up it gets. All right, boys, I think we got lucky here. I could still turn the pin by hand, though tight, with the top and bottom welded in. So it's not seized in there like this one did, but it'll work. It's definitely, you know, you're gonna have to work this pin to get it in and out. I would imagine after my first job of angling this back and forth and crashing into things, that this will loosen up and that pin will move on its own. We are officially done, minus paint and cleaning, of this damn angle bracket. 4 separate repairs on this angle bracket. That's where 70% of the slop was coming from. I gotta do these 2 bushings out on the C-frame of the Dozer. I'm gonna have to wait though, because there's snow on the ground and it's very cold out. We're waiting on a week to warm up a little bit. All right, so let's do something about this wallered out angle cylinder here. So I don't know if you can see it on camera, but there is a very obvious egg shape to this. Right, you put a pin in here. This is the pin that came out of it. Look at the amount of play that this has. Let's get another angle of this disaster. Right, so that's unacceptable. We do not need that type of play. So let's see what we can save on this. So really there's no way to find a perfect center on this. So what I do is I'm gonna eyeball my X direction and then play with the Y to where I bring the boring bar out. I'm just grazing. I don't know if you can hear that. Just grazing that side. And I just grazed the rust off of this side. So we're very, very close. So I can lock the table there. This hold position doesn't need to be anything in the thousandths. It just needs to be pretty close. So we'll bring this boring bar out a little more. We're contacting over here, we're contacting over here. So we're probably set up to do our first light cut. I'm actually gonna bring this back a little. All right, I'm happy with the center that we're on. So now it's just a matter of taking light cuts and running it till it's round. And this is gonna be a time-consuming process, but there's no other way really. stop and show you this. This is kind of a cool shot. So we're just making a round circle at this point, right? But you can see these low spots here. You can literally see how the pin's been rocking back and forth in there, right? You got low spot there, low spot there, low spot here, and then low spot down there. All right, boys, we made it. I gotta grind the face of this. There's actually a little material peeled up here from that bushing rocking. And now we got a nice round hole right down the middle. It looks a little offset still because the metal's displaced here, but we will get that all cleaned up. See where we landed for size. I took the minimum off to clean it up. We can go bigger if we need to, but I like how much meat is remaining here on this rod end. I'm not worried about this splitting open and pulling out, because some of these smaller ones, you bore them too big, you run out of material here. That's what we ended up taking out. That is pretty substantial, but the good thing is we're gonna have a bushing that has pretty substantial wall thickness, maybe 3/16 of an inch wall thickness or so. So it's gonna be a substantial bushing too, which is also good because you don't wanna bore this just a little bit over and then have a paper thin bushing. It's probably not gonna hold up. So I think this actually worked out in our favor every direction, which, all right, all cleaned up. Man, that looks nice. Let's get it measured up and get a bushing built. I made this and I'm like, oh crap, how am I gonna turn the OD now? I totally overlooked that. I didn't want to do an interrupted cut, so I'm just gonna use the pin as the mandrel since I already threaded the end of it here. And we have this sacrificial piece of aluminum that fits over it. So something like this, I'll clamp that in the lathe, I'll indicate it in round, and then we can machine our OD here. We can cut right into the aluminum, and this will be perfect. Making these cuts 10 thousandths at a time here. This is where having a little lathe really slows you down. I got to bring this all the way down from 2 1/4 to like 1.81. So it's a lot of passes to make it happen. Any more than that, this thing will start slipping the belt or chattering even worse than it already is. Gets the job done, but a heavier lathe would be something I'd be really interested in the future. So it looks like we are going to have some press fit here, which is great, but another thing we cannot forget is to drill a hole in this for the grease fitting. We don't want to end up blocking off our grease port. It's already pulled out the grease fitting. We're going to put a hole in this dead center, and then we can go ahead and hammer it in. Back to the drill chuck. Hood rat trick here to figure out the center of this is when that scale goes level, or pretty close. That looks good to me. And this doesn't need to be perfect. This needs to be ballpark so it lines up with the existing grease hole, which is pretty big, so we got room to play around there. Actually, this ain't that big. I might just go right through with the center drill. Screw it. This turned out excellent. And this old cylinder is saved and ready for another day of dozing. All right, guys, I'm gonna wrap up part 2 here. So we got a lot done in this episode, but we're not quite done yet. We saved this old cylinder here with a fresh bore on the eyelet, new bushing, new pin. That turned out really nice. And then our big challenge was getting the custom bushings made for the main pin here on the angle frame. I think this is going to turn out to be a very robust setup. We got a 2-inch pin through the center here. Should be plenty good. I still need to make a spacer for this like I said I would. And then finally, we got our upper angle bushings and pins done. All this is really good. Look at that. Pin drops right in. No play at all. Extremely happy with how this turned out. So I'm going to get this thing painted as soon as the weather breaks and we get a couple warm days here. And then we're gonna get started on the blade, new cutting edge, a little reskinning, and a couple repairs on that. Stay tuned. I'll see you in part 3 of fixing this sloppy ass John Deere 450B 6-way dozer blade. Thanks for watching Spank Ranch Garage. Talk to you next time.